Let's look at final exam question number 67 in Geometry Demystified, 2nd edition. Please refer to page 362. We're asked about a system of Cartesian coordinates, x, y, and also a set of polar coordinates, theta, the angle counterclockwise relative to the x-axis going out to the right, and r, the radius. Okay, remember that in this book we are treating theta as the independent variable in polar coordinates. Okay, we're working in polar coordinates and we want to know which of the 5 types of curves listed constitutes a true function in polar coordinates, but not in Cartesian coordinates. Well, the short answer is A. You can check each and every one of them according to the vertical line test for Cartesian coordinates and according to the test for polar coordinates, which involves considering each value of the angle and seeing how many values of the radius there are. In polar coordinates, the equivalent of the vertical line test is a radial line test, where we rotate that radial line all the way around once, completely, around a full circle. As we do that, we should never get more than one point at which the curve intersects the radial line, and we can see that the circle will do that in polar coordinates. Now in Cartesian coordinates, the circle will not do that, will not obey the vertical line test, because, for example, here 2 points, 2 points, 2 points. So we know that choice A is the answer just by checking this. Now the others, you'll have to check them one by one yourself. And you can ascertain when you do that that the circle is not a function in Cartesian coordinates, but all of the other 4 curves or lines here are functions. In polar coordinates, the circle is a function. So is this horizontal line up here, but this one along the x-axis here isn't, because right there and right there we get an infinite number of intersections with the radial line. The other curves appear to be, from what I can gather here, these 2 parabolas both would be functions, but not always. We might have a parabola that was, say entirely in the first quadrant up here. In polar coordinates, that would not be a true function. But the answer to this particular question is A, based on the radial line test, going all the way around. Remember again, in this course we are treating the angle as the independent variable and the radius as the dependent variable. The equation of a circle centered at the origin in polar coordinates is always r equals c, where c is some real number constant.